Good day, friends. In this 15th lecture, I will tell you how to write down the descriptions of functions nicely in the graph paper when you draw a function. For example, you have drawn a function sin x, or for that matter, any function. We love to write down the description of the function very near to that curve so that people looking at it can easily understand he has plotted that function. And that I'll be doing by using uh, a beautiful software which is called Latex. That is, Latex is integrated in Geogebra, and I'll be using that. But to do that, you should have some knowledge of writing or some knowledge of grammar of writing in latex the mathematical expressions. Now, so far as writing mathematical expressions are concerned, personally I feel no other software can beat latex. So if you are writing a document which is very much mathematical in nature, then you cannot but choose LaTeX to write that. Okay, let us try to see what I'm trying to mean. For example, you draw a curve sin x, okay, and then I want to write sin x against this curve, okay, and I will be not writing it in plain text. Okay, so let us see how I am doing it. If you want to write some mathematical expressions here in LaTeX, then what you have to do is first step is you have this double quotes here you create. You can write the formula following the LaTeX grammar here between these quotes, but I prefer to write that same thing here by going to its setting and then go to text, then you write it here whatever you want to write, and you choose here serif and let it be small, and then I want to write sin x, so sin x, sin I will write like this, sin, and then x, and this is the latex formula. It looks like this. See, it has come here, inverted comma. Now, this is the grammar that sign, the font of sign, SIN. It is like, looks like ordinary text, but text is different. Looks like a bit curly. Okay, this is the type setting, mathematical expressions. Hopefully it has done so. There I press OK and then come out of it, and you activate this and your sin x come, and you put it against here. You can change its color if you like, simply by, for example, it is a blue curve, write in blue, oh sorry, something like that you can do. It is filled color like that, but nonetheless it has drawn nicely, written nicely that sin s card. Forget about this. I will now select another function and do it. For example, you sketch a function. Okay, delete it and delete it. And for example, you write a function sin x by x. We have used this function several times, rather plotted this function several times earlier. And if you sketch it, it is like this. You can increase its amplitude a bit, 5 say, 5 sin x. Okay, it will be somewhat like this. And you want to write against it this description of the function here, but by using LaTeX, so that the typesetting is beautiful. Okay, so what I will be doing, first step will be do coating here. Then this is how I do sin x. I don't type here anything. Then you go to text. Then you choose serif, small. Then you write this equation following the LaTeX comment. Now it is a fraction. So in LaTeX, the fraction is written like this: A for AC fraction. Then within the second braces, you have to write down the numerator, which is 5 sin x. That I will write now. 5. Then sin x. And then the denominator, that is x here. Where is it has gone? I was editing this, so text. Where that thing? I missed something there. So once again, I write. Please bear with me. Um, I have to write down this function in LaTeX. So fraction, and if for a C fraction, then numerator within these braces, that is 5 sine x. Then the denominator, which is x. Yes, it has come 5 sin x by x. And then you press OK, and your thing should come there. If you activate this, yes, it has come. Okay, got the point. And there is a setting here. The pen color also you can change. This I think pen color. I don't change that. You can try different colors. It can be easily done. So what I want to tell, once you have written, you can put it besides the curve. Hmm? And if you like, you can make it slightly smaller in that text comment, LaTeX comment. This is one curve. Suppose you now sketch another curve, that is, say, this is first curve, and this is, say, another curve, 0.5 x square. It's a parabola, and you want to write the equation of this parabola in LaTeX beside it. So that is fine. You can do it in this fashion. So you produce two quotes, double quotes, and then go to the setting, go to text, LaTeX formula, choose serif font, let it be small, and here you write it is 0.5 x square. This is the grammar of LaTeX. 0.5 x square. You see the font appearance of this mathematical expression. You have done this, then you simply press OK, and it should come here. Once you activate this text, yes, it has come and you put it beside it. So in this way, you can write down the mathematical expression nicely in LaTeX in this fashion. And also a little advanced thing I will tell. For example, you these things I delete all the things. You have understood this. You clear all. Okay, don't save. Now what I will do, you can first write down the equations here also without plotting the cards. In fact, I find it somewhat easier if I write down that equations for example, piecewise functions. Okay, between which limit to which limit I have to draw, I have to write it here less than equal to etc. If x is less than equal to 5, things like that. Then it is better you write down the equations there and then go back there. For example, I will say that I first write down this piecewise function here in LaTeX. Okay, how do I do it? I create double quotes. Of course, whatever equations you want to write for that one curve has to exist. No, it is not like that. You can independently write even some other mathematical descriptions relevant to your curves. Okay, separately. So first I am writing down the equations, although there is no curve yet. So I go to its setting and choose text. Okay, then I choose serif small. Okay, now here let us say I want to write a piecewise function. That is, first of all I write fx equal to, okay, some function fx equal to, um, then I write begin cases following LaTeX grammar. Begin cases. And this should be always backlash, not a vertical line. LaTeX, in LaTeX, it is always this thing. So fx equal to begin cases. Any environment starts with begin cases and end cases. Okay, end cases we'll write at the end. Now, what is the first case? First case is I say that fx equal to, suppose, x squared. Then you write the cases, the range of x squared. Suppose I say x squared will be the function between, say, -1 to +1. Okay, so between -1 here, so -1. Then in LaTeX, less than equal to, you write x, then less than equal to LE, less than equal to 1. Between this range, the function will be x squared. Suppose I write that. Of course, this thing is not going to produce any plot here. To produce plot here, you have to write in the comment line. We have discussed several times. But I am telling you how this equation will be written in this one using LaTeX. So, and then to backlash, uh, to go to the next slide. First, let me type. So, this is the thing. Then I will say this function, piecewise function, will be square root of x. So, sqrt within second braces, that is the grammar of LaTeX, x, then and and you write down the range in which it will be valid. For example, I say it will be between 1 less than equal to x less than equal to say 5. Okay, and then the next line. And in the last line, I say this function should be, the functional value should be uh, 0 elsewhere. So elsewhere is not any mathematical fonts, it is just text form. So in the LaTeX, it is, you have to write it like this. In the midst of the mathematical symbols, you have to write ordinary text. Then you have to go to the text environment and you write it like elsewhere is equal to 0 text elsewhere. And after this no line exists, you have to simply close this thing by saying ain't cases. And you see, it shows you the preview fx equal to x square for x ranging from -1 to +1 is equal to root x 1 to 5 is equal to 0 elsewhere. And you see the mathematical expressions, the font's typesetting is different from this text elsewhere. Oh, made a, here I should put a embrace, and I made a spelling mistake here. Where? Okay, then you press OK, and the same grammar appears here, which I could type here, but I require a bigger screen to do that. That's why I always put two quotes, then go to settings, then type comfortably there. Now, if you activate this, it comes here and it comes so nicely. You can put it anywhere you like. Got the point? So now suppose you now draw this function looking at this, and it is a piecewise function. So what we know how to draw it, and it will help me. Okay, equation is before me. I'll be making least mistake if such equation is before me. So if I will say -1. hmm, Here, of course, the grammar is different. Less than, it has nothing to do with latex. Less than equal to x, suppose, and less than equal to, wait, less than equal to +1, is it? +1. Then comma, and the description of the function, that is x squared, and it has drawn it -1 to +1 fx. Okay, if this is it, but here my things does not end, then I give the next range in the same braces, first brackets, it is equal to sqrt. Oh, no, this thing you simply write sqrt. In case of GeoGebra, sqrt, in the braces you write uh, x, and it draws. But what is its range? Its range is 1 to 5. So you simply draw equal to root x. Then you say it is like this 1 to 5, 1 less than equal to less than equal to x less than equal to 5 and anything went wrong here. Uh, if minus 1 to 1 it is x square. Oh, here I have to put first the range. I meant because root x came earlier. Range, then the function. Okay. So what to do? Yes, delete this root x here. If x is between 1 to 5, then you sketch sqrt_x. Hopefully it has drawn correctly. Yes. So between minus 1 to plus 1 it is parabola, and else 0 is equal to elsewhere. I am not plotting. You can always do it. This one. But what in essence I am trying to tell is that after you do this, you can bring this equation in front of this in close proximity to this piecewise function. It looks like bigger, so you can always go to its setting, text. Okay, it was small, make it further small, very small you make it. Okay, okay, it looks nice. See how beautifully it has written down the equations here. So, mind you, these things, begin cases, end cases, these items written in LaTeX, it has nothing to do with GeoGebra. You have to follow the grammar of LaTeX to write this. Okay, that is what I have written. Okay, and then you uh, go to this, go to text, LaTeX formula. This is where I have written. This is following the LaTeX grammar. And then it will produce this output, and it in essence gives you this nice way of writing mathematical expressions here. So in essence, what is the purpose of this lecture? Those who are conversant with already LaTeX but perhaps do not know how to integrate LaTeX with GeoGebra, they will find it more useful. Thank you so much for viewing this. Hope it will help you. Thank you.